Welcome to this e-learning module on transportation in logistics and supply chain management. Transportation is the engine that keeps supply chains moving, literally. Every time a product travels from a supplier to a factory, from a factory to a warehouse, or from a store to a customer's door, transportation is the link making that flow possible. In this lesson, we'll look at transportation not just as moving goods, but as a strategic function that shapes cost, speed, service quality, and competitiveness. Here's what we'll cover. First, we'll define transportation from a logistics and supply chain perspective, what it includes, and why it matters. Next, we'll examine the major transportation modes, from road and rail to air, sea, pipelines, and intermodal solutions. Then we'll explore the key factors that influence transportation decisions, such as cost, time, reliability, capacity, geography, and product requirements. After that, we'll focus on freight forwarding services and how forwarders help companies move goods efficiently, especially across borders. Finally, we'll dive into transportation cost analysis, how to understand, measure, and optimize one of the largest cost components in logistics. Let's start with a strong foundation: what transportation really means in supply chain management. Transportation is not a standalone activity. It directly affects inventory levels, order fulfillment speed, customer satisfaction, and total logistics cost. When transportation performs well, the supply chain becomes faster and more predictable. When transportation fails, through delays, damage, or capacity shortages, the entire supply chain feels the impact. So understanding transportation is essential for supply chain success. At the simplest level, transportation is the movement of goods, materials, or products from one location to another. But in logistics, transportation is more than moving something from point A to point B. It includes the planning, coordination, and control needed to deliver the right product, in the right condition, at the right time, to the right place, often at the lowest total cost. In other words, transportation is both an operational activity and a strategic decision area. When we talk about transportation in logistics, we're talking about a broad scope of activities. Of course, there is the physical movement using different modes: trucks, trains, ships, aircraft, pipelines, or combinations of these. But transportation also includes loading and unloading, and the packaging and handling required to protect goods during the journey. It includes documentation management, such as bills of lading, commercial invoices, and shipping instructions. It includes tracking and tracing, so companies and customers can see where shipments are in real time. It includes insurance coverage for goods in transit and customs clearance for international shipments. And finally, it includes route planning and optimization, choosing the best routes to balance time, cost, and reliability. Transportation is a system, not a single step. Transportation plays a pivotal role in supply chain performance for several reasons. First, it bridges supply and demand, moving products to where they are needed. Second, it creates value through place and time utility. Products are more valuable when they are available at the right location and at the right moment. Third, transportation is a major cost driver, often representing around 40 to 60% of total logistics costs, depending on the industry and network. Fourth, it directly impacts customer satisfaction, because delivery speed and reliability shape the customer experience. Fifth, transportation can create competitive advantage, either through faster service, better coverage, or lower cost. It also enables global trade by connecting countries, ports, and markets. And at a broader level, transportation supports economic growth by facilitating commerce. Transportation is commonly divided into two categories: domestic and international. Domestic transportation happens within a country's borders and typically uses road, rail, air, or inland waterways. International transportation crosses borders and may involve ocean freight, air freight, cross-border trucking, or international rail, often combined through intermodal solutions. International transportation adds complexity, especially with customs procedures, documentation requirements, security rules, and differences in regulations across countries. Transportation has evolved dramatically over time. One of the biggest turning points was containerization in the 1950s, which revolutionized global trade by standardizing cargo handling and enabling faster, safer transfers between ships, trains, and trucks. The rise of intermodal transportation built on this, improving efficiency by combining modes. Later, just-in-time delivery approaches increased the demand for reliability and tight scheduling. Information technology integration then enabled real-time tracking, better coordination, and improved visibility. More recently, e-commerce growth transformed last-mile delivery, creating higher expectations for speed and convenience. And today, growing environmental concerns are pushing organizations toward more sustainable transportation strategies and lower emission options. Despite its importance, transportation comes with major challenges. Cost management is a constant pressure, especially with fuel price fluctuations and changing market rates. Environmental concerns and emissions regulations are increasing expectations for sustainability. Infrastructure limitations, like congested roads, limited rail capacity, or port bottlenecks, can reduce reliability. Regulatory compliance is another major area, including safety rules, labor restrictions, and international trade requirements. Security risks such as cargo theft, tampering, and fraud also matter. Technology integration can be difficult when many partners use different systems. Capacity constraints can emerge during peak seasons or disruptions. And finally, last-mile delivery is increasingly complex, especially in dense urban areas, rural regions, or under fast delivery expectations. Now let's move to transportation modes. Choosing a mode is one of the most impactful decisions in logistics because it affects cost, speed, risk, capacity, and service levels. Each mode has strengths and limitations, and the best choice depends on the shipment, the customer promise, the network, and the business strategy. We'll review the primary modes one by one and then discuss intermodal solutions that combine them. Road transportation, trucking, is the most widely used mode for domestic shipments and short to medium distances. Its biggest characteristic is flexibility. Trucks can typically provide true door-to-door service, reaching factories, warehouses, retail stores, and homes. Road transport also supports fast delivery over shorter distances and offers variable capacity options, from small vans and box trucks to full-size semi-trailers. Because of this adaptability, trucking is a backbone of modern distribution networks. The advantages of road transport are very practical. It provides accessibility to almost any location with roads, which makes it ideal for pickup and delivery. Scheduling is flexible, allowing companies to match dispatch times with operational needs. For shorter distances, it can be cost-effective and often faster than alternatives when you include loading, transfers, and handling. Road is also suitable for smaller shipments, such as partial truckloads or parcel deliveries. And perhaps most importantly, it is essential for last-mile delivery, where customer service expectations are highest. Road transport has limits. Capacity is restricted compared to rail or ocean shipping, making it less efficient for very large volumes. It is vulnerable to traffic congestion, road conditions, and weather disruptions. It can have a relatively high environmental impact per unit moved, especially when trucks are not fully utilized, and it operates under regulatory constraints such as vehicle weight limits, emission standards, toll systems, and driving hour restrictions designed to improve safety. These factors can affect both cost and service reliability. Road transportation is widely used in distribution and last-mile delivery, where flexibility is critical. It also plays a key role in intermodal connections, moving containers to and from rail terminals and ports. In manufacturing, trucking supports just-in-time operations by delivering components on tight schedules, and at a regional level, trucking enables frequent replenishment across distribution networks, connecting warehouses, cross-docks, and retail locations efficiently. Rail transportation is crucial for long-distance and high-volume shipments, especially bulk goods and containerized freight. Rail offers high capacity and strong energy efficiency, making it attractive for moving large loads over long routes. However, rail operates on fixed routes and schedules. That means it's excellent for predictable corridors, but less flexible when delivery locations are far from rail infrastructure. Rail's advantages are strongest in cost and sustainability for long-haul movement. It is often cost-effective for bulk shipments over long distances. Its carbon footprint per ton-mile is generally lower than trucking, which supports sustainability goals. Rail can also be relatively reliable in adverse weather compared to road in some regions, and it has strong safety performance, especially important for hazardous materials when managed under strict regulations. The limitations of rail mostly come from inflexibility. Rail networks are fixed, so you can't easily reroute to every destination. Rail is typically slower than road for time-sensitive shipments, especially when terminal handling and transfers are included. It also requires significant infrastructure and coordination, and many customers don't have direct rail access, so rail often requires trucks for the first mile and last mile. Rail is ideal for bulk commodities like coal, grain, and minerals. It also supports containerized cargo, especially on major land corridors, linking ports to inland distribution points. Automotive logistics frequently uses rail to move vehicles and components efficiently. And for very large geographies, rail becomes a key option for cross-continental shipments, balancing cost and capacity at scale. Air transportation is the premium option, used for high-value, time-sensitive, or perishable goods. Its defining characteristic is speed. Air is the fastest way to move goods over long distances. It also has global reach, connecting major markets quickly through airport networks. Air cargo services tend to offer high reliability in scheduling, which makes them attractive when delivery deadlines are strict. The biggest advantage of air freight is unmatched speed over long distances, which can shrink lead times dramatically. It can also provide access to remote locations with limited road or sea options. Air cargo typically benefits from strong security procedures at airports, reducing certain risks. Faster delivery can reduce inventory holding costs because less stock is tied up in transit. And for perishable products, like certain foods or medical supplies, air freight may be the only feasible option to preserve quality. Air freight is expensive, with a high cost per unit compared to other modes. Capacity is also limited relative to sea or rail, and weight and volume constraints can be strict. Air transport has a larger carbon footprint per ton-mile, raising sustainability concerns. And it can still be affected by weather, airport congestion, and security-related delays. So air is usually chosen when the product value or urgency clearly justifies the cost. Air transport is commonly used for high-value electronics, where speed and security matter. It is critical for pharmaceuticals and medical products, especially those requiring controlled conditions and quick delivery. Fashion and seasonal items also use air to meet short market windows. Emergency shipments, such as spare parts for halted production lines, often rely on air. And global e-commerce fulfillment increasingly uses air freight to meet fast international delivery expectations. Sea transportation is fundamental to global trade. Ocean freight offers enormous capacity and is generally the most cost-effective option for international shipments over long distances. It connects the world through a global port network and supports nearly every type of cargo, from containers to bulk and project loads. The key trade-off is speed. Sea transport is slower than air and often slower than land routes. Sea freight delivers powerful economies of scale. Moving large volumes by ship dramatically reduces cost per unit. Ocean routes connect major ports worldwide, giving companies access to global markets. Sea transport is versatile, supporting containers, bulk commodities, liquids, and oversized cargo. It also tends to have a relatively lower environmental impact per ton-mile compared to air. And for oversized or heavy cargo that cannot move easily by other modes, shipping is often the best or only solution. The limitations of sea freight are mainly time and complexity. Transit times are long, and schedules can be affected by port congestion, weather, or disruptions. Sea transport has limited inland accessibility because ports are coastal, so additional modes are required to reach inland destinations. Documentation is complex, especially internationally, and compliance requirements can be heavy. Long transit increases exposure to risks like damage, moisture, or handling issues, making packaging and container integrity very important. Sea transportation is essential for bulk commodities like grain, coal, and ore. It is the main method for container shipping, supporting most global manufacturing and retail supply chains. Vehicle transport also relies heavily on specialized ships. Project cargo, such as large industrial equipment, often travels by sea. Overall, sea freight is the backbone of global supply chains due to its capacity and cost efficiency. Pipeline transportation is crucial for moving liquids and gases, and it operates very differently from other modes. Its key characteristic is continuous flow. Pipelines move products 24/7 once the system is in place. Pipelines require fixed infrastructure and large initial investment, but their operating costs can be low once built. The trade-off is limited flexibility, routes are fixed, and product types are generally restricted to liquids and gases. Pipelines are cost-effective for moving large volumes over long periods. They're highly reliable and are less affected by weather conditions than road, rail, or sea. Pipelines can also be safer for certain hazardous materials because the movement is controlled and isolated compared to highways. They often have a lower environmental impact during operation, and the continuous nature of flow supports stable supply for industries and cities. The biggest limitation is the high cost and complexity of construction. Building pipelines requires major capital, permitting, and long timelines. Routes are fixed, limiting responsiveness to new markets or changing demand patterns. Pipelines are only suitable for specific products, mainly liquids and gases. And while operations can be safe, leaks can create serious environmental risks, so monitoring, maintenance, and regulation are critical. Pipelines are widely used in the oil and gas industry, moving crude oil, refined fuels, and natural gas. They also support water supply networks, delivering water across regions. In the chemical industry, pipelines move industrial liquids safely and continuously. Some mining operations also rely on pipelines, for example, transporting slurry mixtures where feasible. Intermodal transportation uses two or more modes in a single shipment, without handling the goods themselves when switching modes. The product stays inside a standardized container, and the container moves from truck to rail to ship and back to truck as needed. This allows a shipment to benefit from the strengths of each mode while reducing handling risk. Intermodal solutions are especially important in international trade and long-distance distribution. Intermodal transport can be very cost-efficient because it combines low-cost long-haul modes, like rail or sea, with flexible road delivery at the endpoints. Because goods remain in the same container, there is less physical handling, which reduces damage risk. Intermodal also supports lower environmental impact when rail or sea replaces long truck routes. It extends reach by connecting global routes with local distribution, and it can improve security, since sealed containers reduce opportunities for tampering during transfers. Intermodal transportation also brings challenges. Coordination is more complex because multiple carriers, terminals, and schedules must align. Transfer points can cause delays, especially if ports or rail terminals are congested. Intermodal often requires higher initial investment in containers, equipment, and systems. And for urgent shipments, intermodal may offer less flexibility than direct trucking or air freight, because fixed schedules and transfer times can limit speed. Intermodal solutions are essential for global trade, connecting factories to ports, ports to inland hubs, and hubs to final destinations. Retail and e-commerce use intermodal to move large volumes efficiently while maintaining broad coverage. Manufacturing supply chains use intermodal for predictable, recurring flows of components and finished goods. Bulk commodity transport also benefits when long-haul efficiency and capacity are priorities. Transportation continues to evolve through new technologies. Hyperloop concepts aim to move cargo at very high speeds through low-friction systems. Cargo drones are being tested for remote deliveries and fast small shipments. Underground freight networks could reduce urban congestion by moving goods below city streets. Autonomous vehicles may improve safety, reduce labor constraints, and enable more consistent operations. Maglev freight systems, using magnetic levitation, could offer future high-speed cargo movement. While not all of these are widespread today, they show where innovation may reshape logistics in the coming years. Choosing a transportation mode or strategy requires balancing multiple factors. Rarely is there a perfect option. Decision-makers must weigh costs against delivery speed, reliability, risk, and customer expectations. They must also consider capacity, geographic realities, and the specific characteristics of the product being shipped. The goal is not just to minimize freight cost, it is to optimize transportation in a way that supports overall supply chain performance. Cost is often the starting point in transportation decisions, but it must be understood in detail. Direct costs include freight charges, fuel surcharges, handling fees, and documentation expenses. Indirect costs are just as important. Inventory carrying costs while goods are in transit, insurance costs, packaging needs, and the cost of potential damages. A cheaper freight rate can become expensive if it increases lead time, raises inventory levels, or increases risk. That's why cost must be evaluated across the full logistics picture. Transportation decisions involve key trade-offs. Speed versus cost is one of the most common. Faster modes like air are more expensive, while slower modes like sea are cheaper, but may require more inventory. Frequency versus cost matters too. Shipping more often improves responsiveness, but can reduce consolidation and increase cost per unit. Capacity utilization versus cost is another balance. Higher utilization lowers unit cost, but may reduce flexibility. This is why many companies use a total cost of ownership approach, considering long-term and system-wide cost impacts, not just the immediate freight bill. Time is critical in modern supply chains. Transit time is the time goods spend moving, and it differs greatly by mode. Lead time is broader. It includes processing, handling, and the end-to-end time from order to delivery. Lead time directly affects inventory and responsiveness. Longer lead times usually require more safety stock. Time-sensitive goods, like perishables or trend-driven products, often require faster transportation even at higher cost. Just-in-time systems also demand dependable timing because late deliveries can stop production. And many customers require specific delivery windows, making schedule precision essential. Reliability is the ability to deliver on time consistently. For companies operating tight schedules, reliability may matter more than pure speed. On-time performance affects production planning and customer satisfaction. Variability in delivery time increases uncertainty and forces companies to hold more safety stock. Different modes and carriers deliver different levels of consistency. Reliability can be influenced by weather, infrastructure quality, congestion, and operational discipline. In many contracts, service-level agreements define required performance levels, making reliability a measurable and managed expectation. Capacity and availability can strongly influence transportation choices, especially during peak seasons or disruptions. Load capacity varies by mode. Ships and trains can carry far more than trucks or aircraft. Seasonal fluctuations, such as holiday peaks or harvest seasons, can reduce availability and increase cost. Specialized equipment, like refrigerated containers, tankers, or flatbeds, may be limited. Network capacity constraints at ports, airports, and rail terminals can create bottlenecks. Many companies must decide how much capacity to secure through long-term contracts versus how much to leave flexible for spot market opportunities. Geography shapes transportation decisions in very practical ways. Distance affects both cost and feasible mode choices. Terrain and infrastructure availability may limit options. For example, rail access may be limited in certain regions, or roads may be challenging in mountainous areas. International shipments add border crossings, customs procedures, and potential delays. Political relationships and regulatory differences can influence routing choices. Proximity to transportation hubs like ports, airports, and rail terminals affects both transit time and cost. And urban versus rural deliveries create different challenges. Cities face congestion and restrictions, while rural areas face longer distances and lower delivery density. The product itself is a major decision driver. Size and weight may require specialized equipment or limit mode choices. Value density, value relative to size or weight, often determines whether expensive fast transport makes sense. Perishable products require temperature control, and sometimes faster modes to protect quality. Hazardous materials face strict regulations that may restrict routes, carriers, and handling procedures. Even product lifecycle matters. Early-stage launches or seasonal items may require speed, while stable products may prioritize low cost and efficiency. Beyond the major categories, other factors also influence transportation decisions. Customer service requirements, like delivery options, tracking visibility, and return handling, can shape the network. Environmental considerations are increasingly important as companies measure emissions and set sustainability targets. Risk management matters too, including theft risk, geopolitical disruptions, and damage probability. Finally, available technology systems, like a transportation management system, affect how well a company can plan, execute, and optimize transportation. In practice, the best decisions come from balancing all these factors rather than focusing on only one. Now let's examine freight forwarding services. Freight forwarders play a crucial intermediary role in logistics, especially when shipments involve multiple countries, multiple carriers, and complex documentation. Many companies rely on forwarders to simplify transportation execution, reduce administrative burden, and access broader carrier networks. Understanding what forwarders do and how to select them can significantly improve global logistics performance. Freight forwarders are specialized service providers that organize shipments for businesses or individuals, moving goods from manufacturers to markets or final destinations. In ocean freight, many forwarders operate as NVOCCs, meaning non-vessel operating common carriers. This usually means they don't own the ships, but they purchase capacity and resell it, often providing consolidated services and end-to-end coordination for shippers. A freight forwarder's responsibilities cover many critical tasks. They arrange transportation and book cargo space across different modes. They manage shipping documentation and ensure it is correct and compliant. They handle customs clearance, including coordination of duties and regulatory requirements. They may coordinate warehousing and distribution at origin or destination. They can arrange cargo insurance and support claims processes when incidents occur. They also provide consulting on regulations, helping companies avoid costly compliance mistakes. Many offer tracking and status updates for shipment visibility, and they often consolidate smaller shipments to reduce cost, especially in international freight where full container volumes may not be available for every shipper. Freight forwarding comes in different forms. International freight forwarding focuses on cross-border transportation and customs processes. Domestic forwarding manages shipments within one country. Some forwarders specialize by mode, such as air freight forwarders or sea freight forwarders. Others manage project cargo, which involves large, complex, or oversized shipments requiring specialized planning. Many provide specialized handling for perishables or dangerous goods. Increasingly, forwarders also support e-commerce fulfillment services, integrating warehousing, order processing, and last-mile delivery. Using a freight forwarder offers several advantages. Companies gain access to specialized expertise in shipping rules, documentation, and international procedures. Forwarders can deliver cost savings through volume discounts and optimized routing, leveraging their buying power. They improve time efficiency by streamlining paperwork and customs processes. They provide access to established networks, relationships with carriers, agents, and terminal operators. They offer flexibility for different shipment sizes, from small consolidated loads to large projects. They contribute risk management capabilities through experience and planning. They often provide improved visibility through tracking systems. And most importantly, they allow businesses to focus on core operations while outsourcing logistics complexity. Freight forwarding is valuable, but it has challenges that must be managed. Freight rates can fluctuate due to market conditions, fuel prices, and capacity shifts. Service quality can vary among providers, so selection matters. Liability and insurance terms must be clearly understood, especially when multiple parties handle cargo. Communication challenges can arise when many stakeholders are involved across time zones. Technology integration between a shipper's systems and a forwarder's platform can be difficult. Regulatory compliance requires constant attention as rules change. And security concerns, especially for high-value goods, must be addressed through controls, visibility, and trusted partners.